Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today's topic is setting and hardening of cement. Today's topic is setting and hardening of cement. In this session, I am going to cover these topics: cement and composition of Portland cement and setting and hardening of cement. In this session, I am going to cover these topics: composition of Portland cement and setting and hardening of cement. See, cement. The concrete is most widely used non-metallic material in constructions of building, dams, bridges, highways, etc. Concrete is most widely used non-metallic material. It is a non-metallic material in construction of buildings, dams and bridges, highways. We use this concrete or non-metallic material in the construction of buildings, dams and bridges and highways, etc. In concrete, cement is the essential bonding material which binds sand and rock when mixed with the water. In concrete, the cement is the essential bonding material. The cement is the essential bonding material which binds between sand and rock when mixed with the water. In concrete, cement is essential bonding material or binding material which binds the sand and rocks when mixed with the water. Cement is a grey, green or blue-grey heavy powder and finds its importance as a building material. The cement is a grey, green or blue-grey heavy powder and finds its importance as a building material. It can be described as a material possessing adhesive and cohesive properties. It can be described as a material possessing adhesive and cohesive properties and capable of bonding materials like stones, bricks, buildings blocks, etc. It can be described as a material possessing adhesive and cohesive properties and capable of bonding materials like stones, bricks and building blocks, etc. Cement has the property of setting and hardening in the presence of water, so it is called as hydraulic cement. Cement has the property of setting and hardening in the presence of water, so it is called hydraulic cement. The essential constituents of cement used for the constructional purposes are compounds are calcium and calcareous and aluminium plus silicon or argillaceous. Okay, these are the main compounds in a cement. What is concrete is the most widely used non-metallic material in constructions like buildings, dams, bridges and highways, etc. In concrete, cement is the essential bonding material or binding material which binds the sand and rock when mixed with water. The cement is a grey-green or blue-grey heavy powder and finds its importance as a building material. Cement is a grey-green or blue-grey heavy powder and finds its importance as a building material. It can be described as material possessing adhesive and cohesive properties and capable of bonding materials like stones, bricks, building blocks, etc. It can be described as a material possessing adhesive and cohesive properties and capable of bonding materials like stones, bricks, building blocks, and etc. Cement has the property of setting and hardening in the presence of water. Cement has the property of setting and hardening in the presence of water. So it is called hydraulic cement. The essential constituent of cement used for the constructional purposes are compounds of calcium or calcareous or aluminum plus silicon, that is called argillaceous. Okay. The classification of cement. See, the cement is classified into 4 types. These are the classification of cement. The cement is classified into 4 types based on the chemical composition. The cement is classified into 4 types. One is natural cement. The next one is Pozzolana cement and slag cement. Third one is slag cement. The fourth one is Portland cement. The first one is natural cement. The cement is classified into 4 types. The first one is natural cement. The next one is Pozzolana cement. The third one is slag cement. The fourth one is Portland cement. Of this, Portland cement is the most widely used cement. Most widely used cement. In these 4 types, the Portland cement is used widely. Okay, the Portland cement. Now we are going to learn about the Portland cement. It is most widely used non-metallic material of construction. It is the mostly widely used non-metallic material of the construction. Okay, non-metallic material we have to use in the construction purpose. It is a mixture of calcium silicates and calcium aluminates with small amount of gypsum. The Portland cement is a mixture of calcium silicates and calcium aluminates with a small amount of gypsum. The name Portland cement is used because this powder on mixing with water gives a hard stone-like mass which resembles Portland rock. Okay, the name of Portland cement is used because this powder on mixing with water, it gives a hard stone. It gives a hard stone-like mass which resembles Portland rock. That's why we call Portland cement. The cement is classified into 4 types. Okay, based on the different types of chemical composition. The first one is natural cement. The next one is Puzzolana cement, and the third one is slag cement, and fourth one is Portland cement. Okay, the Portland cement is the most widely used cement. The Portland cement. See, now we are going to learn about Portland cement. It is mostly widely used non-metallic material. It is most widely used non-metallic material in the construction field. It is a mixture of calcium silicate. Portland cement is a mixture of calcium silicate and calcium aluminate with a small amount of gypsum is present. The name of Portland cement is used because the powder on mixing with water gives a hard stone-like mass which resembles to the Portland rock. That's why we call Portland cement. The functions of the ingredients in cement. See the functions of the ingredients in the cements. The first one is lime. Okay, this ingredient present in this cement. The lime is the principal constituent of cement. The excess of lime reduces the strength of the cement. Because it makes the cement to expand and disintegrate due to quick setting. What happens? Lime is the function of the cement? What is the function of the lime present in the cement? See, lime is the principal constituent of the cement. The excess of lime, if the excess of lime is present in this cement, what happens? It reduces the strength of the cement. Because it makes the cement to expand and disintegrate. Due to the quick setting. The next ingredient is silica. The next ingredient present in the cement is silica. It imparts strength to cement. This is the purpose or function of the silica. The next one is alumina. It is responsible for the setting action of the cement. The excess of alumina makes the cement quick setting. Okay, this is the function of alumina. The fourth one is iron oxide. The function of iron oxide present in the cement. It provides a color strength and hardness to the cement. And the fifth one is sulfur trioxide. The presence of small amount of sulfur trioxide imparts soundiness to cement. The sixth point is gypsum. It acts as a retarding agent for quick setting of cement. Okay. The functions of the different ingredients present in the cement. See, the first one is lime. Lime is the principal constituent of cement. The excess of lime reduces the strength of the cement because it makes it cement to expand and disintegrate due to the quick setting. The next ingredient is silica. It imparts the strength to cement. The next one is alumina. It is responsible for the setting action of cement, and excess of alumina makes the cement quick setting. The fourth ingredient is iron oxide. It provides color strength and hardness to the cement. The next one is sulfur trioxide. Presence of small amount of sulfur trioxide imparts soundness to the cement. The next ingredient is gypsum. It acts as a retarding agent for quick setting of cement. The properties. All Portland cements are hydraulic in nature. Means it attracts the water. It reacts with water form a solid-like structures. The chemical composition of the Portland cement. This is the chemical composition of the Portland cement. The Portland cement is a chemically defined as a finely grounded mixture of silicates and aluminates of calcium, varying compositions. It approximate chemical compositions are given here. Okay, the Portland cement is chemically defined as a finely grounded mixture. Okay, the Portland cement is the chemically defined as a finely ground mixture of silicates and aluminates of calcium, varying composition. It contains different varying composition like silicates and aluminates and calcium, and its approximate chemical compounds are presented here. See here the name of the compounds present here. Here the formula, and this is a symbol, shortcut symbol, and percent, how much percent is present. The first one is dicalcium silicate. Dicalcium silicate. Then nothing. The formula for the dicalcium silicate is di means 2. The calcium oxide plus silicon dioxide. The calcium oxide and silicon dioxide. This is called dicalcium silicate. This is the short symbol. See how many CaOs are there? 2 CaOs are there. So CEO indicates with C. Sulfur silicon indicates with S. Okay, in shortcut form 2 CaO nothing but dicalcium. C2 nothing but dicalcium. S nothing but silicate that SiO2, silicon dioxide. Okay, dicalcium silicate nothing but di means 2. Calcium is 2 calcium oxides are there. Okay, that is 2 CaO dot silicate nothing but SiO2. The shortcut form is CaOC2S. This is the shortcut form for the dicalcium silicate. The percentage of dicalcium silicate is 25%. The next compound present in the Portland cement is tricalcium silicate. The next one is tricalcium silicate. Calcium nothing but CaO. Okay, tri means 3 CaO. Silicate nothing but SiO2. Okay, the short formula is C3S. C3S. Okay, 3 CaO SiO2 C3S. This is the short form of the tricalcium silicate. The percentage of tricalcium silicate present in the Portland cement is 45%. Okay. Then the tricalcium aluminate. Tricalcium aluminate nothing but Al2O3. Okay, the short form is A. Okay, tricalcium nothing but 3. Calcium nothing but CaO. Calcium oxide 3 CaO. Aluminate nothing but Al2O3. The short form for the tricalcium aluminate is 3C3A. This is the short form of the tricalcium aluminate. Tricalcium aluminate. That is, it contains 10%. The Portland cement contains 10%. The next compound present in the Portland cement is tetracalcium aluminoferrite. Okay, tetracalcium aluminoferrite. Calcium nothing but CaO, aluminum nothing but Al2O3, ferrite nothing but Fe2O3. Fe2O3. Okay, this is the ferrite. The short form for the tetracalcium aluminoferrite is tetra nothing but 4. Okay, 4 CaO and aluminum nothing but Al2O3, ferrite nothing but Fe2O3. The short form for this is the tetracalcium nothing C4, aluminum nothing but A, the ferrite F. Okay, the short form for ferrite is F, C4F. This is the short form of the tetracalcium aluminoferrite. It contains 9%. Okay, the fifth compound is calcium oxide. The fifth compound is calcium oxide. The short formula for calcium oxide is CaO. There is no short form. This is the formula for the calcium oxide. The calcium oxide present in the this Portland cement is 9%. Sorry, 2%. The next compound is magnesium oxide. The formula for the magnesium oxide is magnesium MgO. Okay, it contains 4%. Then calcium sulfate. This is formula, chemical formula is CaSO4. It contains 5%. These are the different chemical compositions present in the Portland cement. What are those? See, dicalcium silicate. The formula, the chemical formula is 2CaO SiO2. The short form is C2S. It contains 25%. The next is tricalcium silicate. That is the formula is 3CaO SiO2. The short symbol is C3S. It contains 45%. The next compound is tricalcium aluminate. 3CaO Al2O3. The short form is C3A. It contains 10%. Then the next one is tetracalcium aluminoferrate. Tetracalcium aluminoferrate. The formula, chemical formula is 4CaO Al2O3 Fe2O3. The short form is C4AF. It contains 9%. The next one is calcium oxide. The formula is CaO. It contains 2%. The magnesium, next one is magnesium oxide. It contains 4%. Next one is calcium sulfate. It contains 5%. These are the composition present in the Portland cement. Setting and hardening of cement. Setting and hardening of cement. Cement, when mixed with water, forms a plastic mass called cement paste. Cement, when mixed with the water, forms a plastic mass called cement paste. During the hydration reaction, gel and crystalline products are formed. During the hydration reaction, the gel and crystalline products are formed. The insoluble gels and crystals have the ability to surround inert materials like sand, bricks, and crushed stones, etc. The insoluble gels and these crystals have ability to surround inert materials like sand and bricks, crushed stones, etc. See, this is the cement or mortar or concrete. This is called setting. Okay, na? This is called setting. After some time, it forms like stone-like structure, that is hardening. Okay, this is the setting. This is the hardening. See, cement when mixed with the water, it forms a plastic mass called cement paste. Okay, the plastic first it forms the cement paste. It will form when reacts with the water. During the hydration reaction, when water reacts with cement, forms the hydration reactions. Okay, during the hydration reaction, gel and crystalline products are formed. During this reaction with water, it forms gel and crystalline products. The insoluble gels and crystals have the ability to surround inert materials. Okay, these insoluble crystals have ability to surround inert materials like sand, bricks, crushed stones, and etc. Okay, this process of solidification comprises of setting and then hardening. First, it will take setting process and then it complete hardening. Okay, the process of solidification, it consists of two types. One is setting and the next one is hardening. First setting takes place, then hardening takes place. See, setting. It is defined as the stiffening of the original plastic mass. First, it will form plastic mass with water. Okay, it is defined as the stiffening of the original plastic mass. The stiffening of the plastic mass is called setting due to the formation of the tobermonite gel. Due to the formation of tobermonite gel, the original plastic mass converted into stiffness. Okay, that is called setting due to the formation of the tobermonite gel. The next one is hardening. It is defined as the development of the strength due to the formation of the crystal. It is defined as what is hardening? It is defined as the development of strength. The strength will be generated due to the formation of the crystal. Okay. The setting and hardening of cement is due to the formation of interlocking crystals. The setting and hardening of the cement is due to the formation of interlocking crystals reinforced by rigid gels formed by the hydration and hydrolysis of the constitutional compounds. The setting and hardening of cement is due to the formation of interlocking crystals reinforced by rigid gels formed by the hydration and hydrolysis of the constitutional compounds. See, these are the reactions involved in the setting and hardening of the cement. In the day 1, see what happens? Reactions involved in the setting and hardening of the cement. In day 1, when the cement is mixed with water, when the cement is mixed with water, at first hydration of tricalcium aluminate takes place. Okay, in the first step, the cement contains different type of compositions. Okay, in that first day, the tricalcium aluminate takes. The tricalcium aluminate, the formula is 3CaO Al2O3. This is the formula for the tricalcium aluminate. Okay, when reacts with water. Okay, at first hydration of the tricalcium aluminate takes place rapidly within 1 day. Okay, within 1 day, it reacts, tricalcium aluminate reacts with the water. Okay, and the paste becomes quite rigid within a short time. Okay, and the paste becomes quite rigid within a short time, which is known as initial set or flash set. Okay, within less time. Okay, now within short time, when reacts with water, the tricalcium aluminate reacts with water, it forms a quite rigid, quite rigid substance that is called initial set or flash set. Okay, the tricalcium aluminate reacts with water. Tricalcium aluminate, short form is C3A. Tricalcium aluminate reacts with water. It forms a 3CaO Al2O3. 6 hydration takes place. Okay, it absorbs the water. It is a exothermic reaction. Okay, it is a exothermic reaction. It releases the heat while forming this type of hydroxide aluminate crystalline. This is the crystal. It is the formation of the crystal. Okay, the 3CaO L2O3 tricalcium aluminate reacts with water in the first day. It forms a initial set or flash set. That is 3CaO Al2O3 6H2O. It is the exothermic process. Okay, in short form we can write C3A reacts with water. Okay, it forms a hydrated tricalcium aluminate. It is a crystalline in form. This is the flash set or initial set. Day 1 it takes place. In day 1 what happens? Tricalcium aluminate reacts with the water, forms a hydration reaction. It forms a flash set or initial set. That is the crystal. That is a hydrated tricalcium aluminate crystals it forms in the day 1. In order to retard the rapid hydration of a C3A or tricalcium aluminate, in order to retard the rapid hydration of a place, okay, early initial setting, gypsum is added to prevent the rapid hydration or early initial setting. Okay, the initial setting stop the initial setting to prolong the initial setting or initial set of cement. Gypsum is added during the grinding of cement clinkers. Okay, gypsum is added during the grinding of cement clinkers. Gypsum reacts with tricalcium aluminate. Okay, gypsum reacts with the tricalcium aluminate to give insoluble calcium sulfoaluminate. Insoluble calcium sulfoaluminate complex, which does not possess hydrating property and retards early setting of cement. It prevents the early setting of the cement. Okay, in order to retard the rapid hydration of the tricalcium aluminates, okay, early initial setting, to stop the early setting or initial setting, the gypsum is added during the grinding of the cement clinkers. The gypsum is reacts with the C3MS tricalcium aluminate. It gives the insoluble calcium sulfoaluminate. It gives the insoluble calcium sulfoaluminate complex, which does not possess hydrating property. It does not possess any hydrating process and retards early setting of the cements. It prevents the early setting of the cement. See, tricalcium aluminate means 3CaO Al2O3 reacts with gypsum. Gypsum formula is calcium sulfate 2H2O. This is the formula for the gypsum. Calcium sulfate water. Okay, 2H2O. That is called gypsum. This tricalcium aluminate reacts with the calcium sulfate 2H2O, nothing but gypsum. It forms the C3A means 3CaO Al2O3 CaSO4 2H2O. That is called calcium sulfoaluminate. It forms the calcium sulfoaluminate solid. Okay, it prevents the initial setting of the cement. And other, it prolongs the initial setting of the cement. See, there are reactions in the day 2 to day 7. Day 2 to day 7. See, after the hydration of C3 and C3S begins to hydrate to give tobermonite gel and crystalline CaOH2. Okay, after the hydration of tricalcium aluminate, then what happens? The tricalcium silicates begins the hydrate to give tobermonite gel. Okay, now then in the first day 1 the tricalcium aluminate reacts. The day 2 to day 7 the C3S, nothing but tricalcium silicates, start the reaction with the water. It forms the tobermonite gel and crystalline solids like calcium hydroxide. This is responsible for the development of the initial strength of the cement. Okay, na? This is the responsible. The C3S reaction with water. This is the responsible for the development of the initial strength of the cement. It is the development of the initial strength of the cement. The hydration of C3S. C3S nothing but 3CaO, tricalcium aluminate, tricalcium, and S nothing but SiO2, silicates, tricalcium silicates reacts with water. Okay. The hydration of C3S, 3CaO, SiO2 gets completed within 7 days. Okay, this reaction will complete in 7 days. It does not contribute much to the strength of the cement. This reaction does not contribute much, okay, to the strength of the cement. See the reactions between the C3S and water. See, 3CaO, SiO2, tricalcium and silicate, tricalcium silicate reacts with water. It forms tobermonite gel, that is 3CaO, 2SiO2, 3H2O. This is called tobermonite gel, and 3CaO is calcium hydroxide. This is a crystalline. It is a exothermic reaction. Okay, in short form, the C3S reacts with water. It forms C3S2, 3H2O. This is the tobermonite gel, and this is the crystalline solid, that is calcium hydroxide. It is a exothermic reaction. This reaction, the reaction between C3S and water, it does not contribute much to the strength of the cement. This reaction will take place day 2 to day 7. In the day 1, the tricalcium aluminate reacts with water. Okay, that is initial set. To prolong the initial set, we have to add gypsum to that tricalcium aluminate. In the day 2 to day 7, what happens? After completion of reaction with C3A, the water reacts with the C3S, tricalcium silicates. Okay, na? The tricalcium silicates with water reacts with water. It will form tobermohnite gel and crystalline solids. Then the reactions in the day 2 to day 7 to day 8. We have seen day 1 reactions and day 2 to day 7 reactions. Now we are going to learn about day 7 to day 8 reactions. In this dicalcium silicate, nothing but C2S. C2S nothing but 2CaO SiO2. This is the formula for the C2S or dicalcium silicates. Reacts with water very slowly and gets completed in 7 to 28 days. Dicalcium silicates reacts with water very slowly and gets completed in 7 to 28 days reaction. The reaction with the C2S and water, it takes 7 to 28 days. It is a very slow reaction. See, 2CaO SiO2, nothing but C2S. 2C2S reacts with water. 2C2S reacts with water. It forms 3CaO, 2SiO2, 3H2O. That is tobermohnite gel and crystalline solid. That is the exothermic process. It will evolve 250 kJ per kg energy. EW. Okay. Or short form, we can write as 2CaO SiO2 C2S. E2 to keep here and reacts with 4 molecules of water. It forms C3H2, 3H2, nothing but tobermohnite gel and forms a crystalline, that is calcium hydroxide. The increase in strength between 7 to 28 days is due to the formation of tobermohnite gel and crystalline CaOH of both C2S and C3S. The increase in strength between 7 to 28 days due to the formation of tobermohnite gel and crystalline of both C2S and C3S. These are the reason tobermohnite gel and crystalline. So these are the reason for the strengthening of the cement. Though the hydration of the tetracalcium aluminoferrite, though the hydration of the tetracalcium aluminoferrite takes place initially, the hardening takes place finally through the crystallization of along with the C2S. Okay. The formula for the CO4AF, tetracalcium aluminoferrite. Okay. 4CaO Al2O3. Okay. The formula for the C4A. Okay. Fe2O3 aluminoferrite. 4CaO Al2O3 Fe2O3. This is the formula for this C4AF. This C4AF reacts with water. This C4AF reacts with water. It forms the crystalline 3CaO Al2O3 6H2O crystalline, and this forms a tobermohnite gel. Okay, it is a exothermic process. It evolves 420 kJ per kg. The short form for reaction is C4AF reacts with water. It forms a C3A 6H2O. Okay. Thus, the final setting and hardening of the cement is due to the formation of tobermohnite gel plus crystallization of CaOH2 and hydrated tricalcium aluminate. Thus, the final setting and hardening of cement is due to the formation of the tobermohnite gel plus crystallization of the calcium hydroxide and hydrated tricalcium aluminate. See, now we have seen the day 1 to day 28 reactions. In day 1 reaction I have explained. See, day 1 what happens? In the day 1 the tricalcium aluminate reacts with water. It forms this hydrated tricalcium aluminate crystalline. Okay, na? That is initial set or flash set. Then next, by adding C3A reacts with gypsum, it forms a calcium sulfur aluminate. It prevents the flash setting. Okay. Then the day 2 day 7 what happens? The C3S. After C3A reaction, C3S means tricalcium silicates reacts with water. It forms the tobermohnite gel and crystalline. So, and it is the exothermic reaction. These two are the reason for the strength of the cement. Then day 7 to day 78 what happens? It reacts with the dicalcium silicates reacts with this dicalcium silicates. Okay, dicalcium silicates with water. It forms tobermohnite gel and crystalline. Day 7 to day 28. Then the last what happened? The C4AF tetracalcium aluminoferrite reacts with water. It forms the crystalline gels. Okay. These are the difference between setting and hardening of the cement. See, setting. Setting is the term used to describe the stiffening of the cement paste. Setting is the term used to describe the stiffening of the cement paste. Is called setting of cement. Then hardening of cement is, hardening refers to the gain of strength of a set of cement paste. Hardening refers to the gain of strength of a set of cement paste is called hardening. It refers to the change from fluid to a rigid state. It refers to a change from a fluid state to the rigid state is called setting of cement. It refers to the formation of solid mass possessing good compressive strength. It refers to the formation of the solid mass possessing good compressive strength. This is called hardening of cement. The setting of cement starts after 30 minutes from the instant. Okay, the setting of the cement starts from after 30 minutes from the instant when water is added to the cement and compacted within 10 hours. It is completed within 10 hours. The setting of the cement starts from after 30 minutes from the addition of the water and it completed within the 10 hours. Okay, hardening of cement. The process hardening of cement continues for a period more than 1 year. More than 1 year, the hardening of cement takes place. To know the setting of cement, initial setting time test and final setting time test are conducted. To know the setting of the cement, initial setting time test and final setting time test are to be conducted. To know the hardening of cement, the compressive strength test to be conducted. To know the hardening of the cement, the compressive strength test is conducted. Okay. Conclusion. Understanding the setting and hardening process of a cement is essential for achieving the desired performance and durability of the concrete structures. Understanding the setting and hardening process of cement is essential for achieving the desired performance and durability of the concrete structures. Proper mix design, curing, and quality control during constructions are crucial aspects of ensuring optimal cement setting and hardening process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.